Number 1 took me 17 minutes, and my little daughter is up, so I may have to do something a little short in this video. Maybe I'll do question number 6 here. Question number 6. I was gonna do 2, but I knew that 2 is gonna take me about 20 minutes too. Oh crap, this looks bad. But you know what? We can do this. This looks short. It's like a multiple choice. So it says, determine which graph is the derivative of the other and explain why. Okay, so they gave us 2 graphs. I saw. I have a blue graph and a red graph. So I opened it up really big for you. So I can see that the blue graph is a W-shaped function, and the red graph is well, okay, I think I can tell the answer already. Because, guys, you know how when you are taking derivative, you go down 1 in the exponent, right? Like, suppose that you have a 5th degree function. Let me open up my notepad so that I can write down what I am saying, okay? I have a baby and a laptop and an iPad and everything on my lap, so I can't find my stuff. Okay, here it is. So do you agree with me if I tell you that if suppose that f of x is x to the 5th power, then f prime of x, the derivative, wouldn't that be 5 times x to the 4th power, right? So the derivative will be 1 degree less. Just by knowing that, I think we can solve this problem, because higher degree functions have more turning points. And I can see the blue graph has 1 turning point, 2 turning point, and 3 turning points, because this is a W-shaped function. You know, you see what I mean by 3 turning points. Like when I'm drawing a W, I must draw, hold on, let me try to, 1 turning point, 2 turning point, and 3 turning point. I have 3 turning points, okay? But the other graph that I noticed, the red one is a little crazy one. I have 1, you see the red one is turning a little more. I have a feeling the red graph is a higher degree function. Okay, so what I know is the red must be the original and blue must be the derivative. I'm just gonna go ahead and use that much without even looking at the increasing and decreasing and all that. Let me see if I can answer this by maybe doing just that much. I think G is the derivative because it has less turning point. G is the derivative of the function, and this is a multiple choice. Oh, A and B both say it. So I'm gonna have to go and talk a little more about why G is a derivative, okay? Click on G, A is the right answer, but I want to explain the second part of it. It says G equals 0 at all values of X where H has a relative minimum or maximum. Now let's talk about that, okay? If you look at the red graph, if you try to sketch, I wish I can draw a picture on the screen. Hey, let me try something. Hold on, Luna. If I take a picture of this screenshot, and is there a way for me to send it to my iPad? Sue's iPad, it says. And maybe Sue's iPad will get to how beautiful. Okay, look at this, guys. So, if I'm going to plot some points here, there is a point right there. And the reason I plotted a point there is because the tangent line is going to be horizontal there. I can sketch a horizontal tangent there, which means the slope of the tangent line is 0. I have a relative maximum there. You see, in the blue graph, on that very same vertical line, the blue graph touches the x-axis. So what they are saying is where at this very point, H, I'm confused with these numbers here. Where H has relative maximum, I'll write that down. Where, I can get a pen tool, where H is the red graph, H has relative maximum, and you agree with me, right? Let me try to make this a bit bigger so you can see my writing. Where H is relative maximum, which is over here, do you see on that same vertical line the g of x, g of whatever this value is, like close to -2, g of this x is equal to 0. You see that? Because relative maximum happens where the tangent line has a slope of 0, where we have a horizontal tangent. So horizontal tangent means the derivative is 0. So I saw that for this first point. There are some other points too, but another point that I noticed is there is a relative minimum over here. See, that point is a relative minimum on the red graph. Okay, it's all right. I may have to stop this soon. But you see how on the blue graph, it is where it touches the x-axis. So g of this x value, I'll just call it x2, is equal to 0. And everywhere the red graph has a relative maximum or relative minimum, and I know that in the middle, like at the origin, I put my pencil down so I can't really talk, but you see over here, oh, Jesus. It's not exactly, how about if I try to draw a box on it? I wish I had free hands for real. Oh, I can draw with my mouse. Look at this point for me, that point right there. That is not a relative maximum or relative minimum, okay? It's just, looks like a point of inflection really. But remember when we were doing these problems, a critical value doesn't really have to be a relative maximum or minimum if the graph to the left and graph to the right is both decreasing or increasing. So you see, it didn't change the behavior to the left and right of this very point. But still, the critical value, it could be critical value because it looks like the derivative is 0. But what I can see is I can try to fit in a horizontal tangent here. I can still draw a horizontal tangent. Maybe I can use this line to, oh, frick. Okay, I'm just gonna give up. But do you see what I mean? How wherever it has relative maximum and relative minimum on the red graph, the blue graph touches the x-axis, which means g has a function value of 0. So A is talking about that. A is talking about that. So at first I was trying to just identify the derivative by looking at which function has smaller number of turning point, because degree of a derivative is always one lower than the degree of the original function. But I had to remember that the derivative is 0 wherever a function has relative maximum or minimum to compare, to tell which is the right answer in between A and B, because B was talking about inflection point. But first derivative is going to give us the critical values where a function can have relative maximum or minimum. Therefore, A is the right answer. I'm going to go ahead and click on check. See, I thought I could do this very quick, but check answer, and that is the right one. I'm going to stop this recording. Maybe I can do one more today.